So this question says, find this using De Mor's theorem. Well, actually, you don't really need De Mor's theorem. You just need to find this thing cubed. So you could have FOIL twice and get the answer. But when we get to numbers where, like the next one, to the 8th power, you really don't want to FOIL this 7 times and risk doing it wrong. So we're going to use De Mor's theorem and do it really quickly. According to De Mor's theorem, you need to change this into the trigonometric form. So we need r and theta. Basically, we got to get into the r cis theta form. Since we just practiced, let's have you try it. So you got to find, so let's call this number z. And you got to find z in r cis theta form. So go ahead and do that, and then we'll finish the rest. This is going to be 2 cis 60 degrees. I think most of you put it in degree sign. Okay, now that we know that this number, this complex number, 1 plus I root 3 is really 2 cis 60, we can use De Mor's theorem that says z cubed is equal to what, according to the formula on the previous page? R to the n. Okay, r to the n, so r cubed. Uh-huh. And then cosine. And 3 theta. Plus I sine 3 theta. Yes. So according to the theorem, this is what we do if we want to find the cube of that complex number. Now we just apply. R in this case is 2, so this is 2 cubed. Cosine 3 theta means 3 times 60 degrees. And then I sine 3 times 60 degrees. Okay, the question doesn't say what form they want the answer in. So you can write this in trigonometric form, or you can write this in standard form, which is a plus bi. Let's finish. So this is going to be 8. Let's say that we write this in r cis form, the trigonometric form. What angle will we use? Or what is the final angle? 180. So CIS 180 degrees. Let's say that we had to change it into standard form, a plus bi form. What would we have to do? Distribute and then multiply everything out, right? So a cis 180 means 8 cosine 180 degrees plus I sine 180 degrees. What is cosine 180 degrees? Negative 1. So this is really just saying 8 times negative 1 plus, and then sine 180 is 0. So I times 0. So basically this number is negative 8. So we have z cubed, or 1 plus I root 3 cubed. We either get 8 cis 180, which is the trigonometric form, or the number is really just negative 8. Does that make sense? Okay, let's try another one. So we're going to find this number, this complex number to the 8th degree, or 8th power. It is not easy to do by FOILing, so it's much easier if we change it into trigonometric form and then use De Mor's theorem to the 8th power. Okay, if you are stuck, please let me know, but basically you got to change this into a r cis theta form. So changing that number into r cis theta form, you should get, 1 cis 135 degrees. Okay, and then just take that to the 8th power. Z to the 8th is equal to 1 CIS and 1080 degrees. Or if you change it to a complex number, it's 1. Good. Okay, the next one is a little bit tricky. Okay, let's look at this polynomial. How many roots should I have? 2. How'd you know it's 2?
Because it's squared.
This squared, right? So what does roots mean? Zeros, yeah. What makes the equation equal to 0, right? So if it has 2 degrees, we should have 2 zeros. And what 2 zeros should I have in this one? Real or imaginary? Real. For this one, it's 2 reals because if you can factor it, right? Okay, so Now, if we say, what are the cube roots of -1, we're basically saying x cubed is equal to -1, and what does x equal to? That's the question. So if I try to solve it, I would do this, right? How many answers am I supposed to get? You're supposed to get 3, but then we would always say x is equal to what? Okay, all right. So if we try to solve this, we should get 3 answers, because x cubed, right? X cubed says we should have 3 answers. But if we do solve it, we get to this point, and then we cube root both sides, and then we get what? -1. Oh, we get -1. Cube root of -1 is -1, not imaginary numbers. So I'm supposed to get 3 answers. Where are the other 2? -1 3 times? No. So there are 2 other answers that we don't usually solve for, that they are available. They are imaginary. And so we need to solve all 3. So this is where we need the theorem in order to help us find the answers quickly. We should have 3 roots, but we don't see 3 roots because they are imaginary. And so what we want to do is use this theorem. And again, this formula is going to be given to you on the test. This is a little bit hard, this following this thing. So please just follow my lead on this. Yes?
I'm just curious for Ch.6.6, since it's like all the formulas will be provided, right?
Yes, section 6, yes. Just section 6. You still have to remember the projection formula, dot product, all that stuff. Okay, so this formula is, if you want to find any of the missing roots, you would do nth root of r times cosine of theta plus 2 pi k over n plus I sine theta plus 2 pi k over n. What does k mean? K means the nth root minus 1. I'll explain what all that means. It's kind of hard to understand. Okay, this will help us find all the missing roots. Sorry, let me leave it up there for you to finish copying first. Okay, everyone's done? What's that? Nth root. Nth root. And then I'll tell you what that means, because that part is a little confusing. Okay, so let's go back to the question. X cubed plus 1 equals to 0. Okay, so if we try to solve that, we would say that x is equal to cube root of -1. So at this time, we can only find one number, that's -1. There are 2 more. So what we want to do is we want to use the formula to tell us where the 3 roots are. And the formula is in terms of trigonometric form. So we got to turn this number, -1, into trigonometric form. Okay, so this number, z, which is -1, is what in trigonometric form? -1 is what? Remember, you got to keep r positive and then angle positive. Radius is 1.
Is 1 and 180.
180 degrees, yes. 1 and 180. Okay, so we are going to find 3 roots. So we're going to call it z1, z2, z3 for the 3 roots. Okay, so z1, applying the formula. Let me rewrite the formula up here so we can all follow along. Whoops, times. Oops, plus. Okay, so first root. According to the formula, nth root of r. N is going to be whatever the root we're looking for. So we are looking for 3 roots, so n is going to be 3. R in this case is 1. Cosine. What's the angle we're looking for, or we're using? 180. Since the formula has pi, I'm going to just erase this and then change this to pi instead. It's just going to be a little crazy if you mix degrees and radians together. So this is going to be cosine of pi plus 2 pi k. K is the nth root minus 1. We're looking for the first root, so k is going to be 1 minus 1. If we're looking at the first root, k is going to be the first root minus 1. If we're doing the second root, k is going to be second root minus 1. If we're doing the third root, k is going to be third root minus 1. It's always 1 less than the root we're looking for. So k is kind of the confusing part. Okay, divided by n. N is 3. Plus, same thing on the sign. Sine pi plus 2 pi times 0 over 3. Okay, now we're going to just simplify this whole thing. Cube root of 1 is 1. We're not looking for all the complex, just the real parts. So that's just 1. Cosine of, okay, pi plus 2 pi times 0 over 3. Pi over 3, yes. Plus I sine pi over 3. Okay, so at this time, we've pretty much done. We found the R6 form of this complex root. Let's say we want to change it into standard form. What would this same number be in standard form? So what is cosine pi over 3? 1 over 2. And then sine of pi over 3? Square root 3 over 2. I. Okay, so the first number is 1/2 plus square root 3 over 2i. That's 1 root. Okay, we have 2 more. And I'm running out of space. Okay.
How did you get k again?
K is the nth root, so the root you're looking for, minus 1. We were looking for the first root, so it's going to be 1 minus 1. We're looking for 3 roots.
Wait, did we already find one now?
We found the first one. There are 2 more roots.
Yeah. So are we looking for the second one?
Yes, we're looking for a second one.
So would k be 1?
K will be 1, yes.
And is there going to be like k be 2?
Yes.
Oh.
Yes, question.
Is that 1 over 2 or pi over 2?
1 over 2.
Alright.
All right, second root. Z2. Okay, nth root of r. So still cube root of 1 times cosine of angle. That angle is still pi plus 2 pi k. K in the second case, again, is nth root minus 1. We're on the second root now, so it's 2 minus 1. So k is 1. Divided by 3 plus I sine, same thing. Any question on this part? I know this is the most confusing part, the k. So, any questions? You sure? Yes. K is, so we're looking for 3 roots. Z1, Z2, Z3. So whatever root number you're on at that time, you take that number minus 1. Yes.
That's why the k, okay.
That's what k is. Yes.
My other question is, how did you get the z equals to -1 and then suddenly equal to 1 CISI?
This part?
Yeah.
Okay, so cube root of square root, cube root of -1 means cube root of z. We're basically saying, what is the cube root of z? Meaning 3 numbers that multiply together will get you -1. So what 3 numbers multiplied together gets you -1 is the question. Well, -1 times -1 times -1 is -1. But that's not the only answer. There are 2 other numbers when you cube them, you get -1. But the question is, what are they? So we don't know. So we're going to use the formula, but the formula is in terms of r cis theta, or trigonometric form. So we have no option but to turn the -1 into a complex number. So -1 needs to become a complex number in the trig form. Everyone else is like, let me just finish this question and move on. Let's do that. Okay, so this is going to be 1 times cosine pi plus 2 pi times 1 over 3. What's that? Pi. And then same thing here. It is -1. Okay, that's my second root. So basically it's saying this number cubed will give you -1, which is true. All right, the second one. Let's do the third one. Z3. Okay, applying the same thing. Cube root of r times cosine of the angle plus 2 pi times k. What's k in this case? 2. Okay, over 3. Plus I sine pi plus 2 pi times 2 over 3. Okay, simplifying all that. That's 1 times pi plus 2 pi times 2 over 3 becomes what? 4 pi over 3? Okay, 4 pi, 5 pi over 3, sorry, 5 pi over 3. 5 pi over 3 plus I sine 5 pi over 3. All right, that's my trig form. What is the same number in complex standard form?
Over 2 plus 1 over 2 minus square root 3 over 2.
Okay, that's my third number. So, if you want to verify if that's any of this is true, you can just go backwards, cube it, and say, is the answer going to be -1? Which they will be. But the most interesting thing is, I'm going to show you this on decimals. We're going to take these numbers and we're going to graph them. Let's do that. Okay, find the fourth root, or the 4 roots. I mean find the 4 roots. 4 roots, not the 4th roots. All 4 roots of this one. This one, they already gave it to you in r cis theta form. You just need to change it. Do you guys need me to help you find the first one? Yes. Okay. We want 4 roots. That means z1, z2, z3, z4. It tells you that r is 5 and the angle is pi over 3. So that's nice. It's already done for you. So z1, according to the formula, nth root of r, 4th root of 5, times cosine of the angle. The angle in this case is pi over 3, plus 2 pi k. What's k in this case?
0.
Yes, 0. Okay, over what?
4.
4, yes. Okay, plus I sine, and then exactly the same thing. Once you do a few of them, you realize that there is a very distinct pattern, and then you can pretty much figure out a lot of them at the same time. Okay, so this is, we're not really going to figure out the answer in the unit circle because it's not in the unit circle. 2 pi times 0 is 0, so this is going to be cosine of pi over 3 over 4. That's pi over 12. Plus I sine pi over 12. So we can pretty much just leave it like that, unless you want to get to the standard form so you can see how it's graphed. Caleb's saying no. That's fine. Just leave it like that. We're all good. Okay, now go find Z2, Z3, Z4. Yeah.
Oh, you do.
Okay, here are the answers, Z2, Z3, and Z4. And we're going to skip the last part, the roots of unity. It's pretty much the same thing, basically saying what's going to equal to 1. So like if it says 8th root of unity means x to the 8th is 1, so you find the 8th root of 1. So same idea. Okay, let me come over and help you.